exercise 5.5. Few questions which are important we will discuss here. Suppose question number, it is question number 4th. Suppose question number 4th and statement is differentiate the function, differentiate the function x to the power x minus 2 to the power sine x. Now, as I have told you in the previous lecture, you can't take log directly to such type of functions. In these functions, you have to take the statement like this: y is equal to x to the power x minus 2 to the power sine x. Suppose let x to the power x is equal to u and 2 to the power sine x is equal to v. Now the function becomes y is equal to u minus v. If you are differentiating with respect to x, you are getting dy upon dx is equal to du upon dx minus dv upon dx. Now our target is to find du upon dx and dv upon dx. Du upon dx can be calculated by using, you have supposed u is equal to what? That is x to the power x. When you take log to this function, you will get log of u is equal to log of x to the power x, or you can write it x into log x. Now differentiate with respect to x. This will be 1 upon u du upon dx is equal to product rule. X as it is, derivative of log x is 1 upon x plus log x as it is, derivative of x is 1. So it is 1 plus log of x. If you shift this u to the right hand side, this comes out. The value of u is x to the power x and 1 plus log x. This is the solution of du upon dx. Now what is v? V is equal to 2 to the power sine x. Now here you can apply log or you can apply the direct formula. When you differentiate this with respect to x, you will get dv upon dx. That will be equal to 2 to the power sine x into log 2 into derivative of sine x, that is cos x. It means the answer of this question will be dy upon dx will be equal to x to the power x into 1 plus log x, and the value of dv upon dx is, that is 2 to the power sine x into log 2 into cos of x. This will be the answer of the question. Now you can do the question number 4th. Now come to the question number next, that is a question number, we'll do next question. That is suppose question number, we will do question number 6. Question number 6 is, x plus 1 upon x whole power x plus x to the power 1 plus 1 upon x. Again, this is a type of variable to the power variable. Question base is in x and power is also in x. Then you will do this question by taking log. For same process, you have to apply. You have to take, this is statement y. This statement is equal to, this is the statement that is equal to y. Now, if you take log, you can't take log directly. Then you have to suppose the first term is u and second term is v. Now, after differentiation with respect to x, dy upon dx will be equal to du upon dx plus dv upon dx. Now, first part you have to do because you have taken u is equal to x plus 1 upon x whole power x. Then by taking log, it becomes log of u is equal to x into log of x plus 1 upon x, like this. Now differentiate it. This is 1 upon u du upon dx. With respect to x, we are doing derivative. X as it is, the derivative of log of t, that is 1 upon t, that is x plus 1 upon x, and derivative of x plus 1 upon x is, derivative of x is 1 and derivative of 1 upon x is minus 1 upon x square. How you are getting derivative? X to the power minus 1 and minus 1 comes out, and x to the power minus 1 minus of 1. Minus 1 it means minus 2. So it is 1 upon x square. Now put here plus sign, that is log of x plus 1 upon x as it is. Derivative of x is 1. Okay. This is now what is du upon dx? Du upon dx will be equal to, that is equal to, take this u to the right hand side, x plus 1 upon x whole power x into this whole statement, this is in into, that will be equal to du upon dx. Now for dv upon dx, you have to take the second statement, that is v, it is given to you. Now I am going to tell you that is equal to, now v. What is v? V is equal to x to the power 1 plus 1 upon x. Now taking log, you are getting log of v is equal to 1 plus 1 upon x log of x. Now applying u into v, this is 1 upon v dv upon dx is equal to 1 plus 1 upon x, first function as it is, derivative of log x is 1 upon x plus log x as it is, derivative of second 1 plus 1 upon x, 1 is 0 and it comes out 0 minus 1 upon x square. Now this is dv upon dx equal to x to the power 1 plus 1 upon x and into, this is equal to 1 plus 1 upon x into 1 upon x minus 1 upon x square into log of x. This is dv upon dx. Now du upon dx we have calculated, dv upon dx we have calculated. Then dy upon dx will be equal to what? Dy upon dx will be equal to, put the value of du upon dx and dv upon dx. What are the values? Put those values. You will get answer. You can simplify it also. In bracket parts, you can solve these parts. After simplification, when you will get answer, that will be equal to, let's see what will be the answer. The answer will be equal to du upon dx, if you simplify this part, you are getting this is equal to x square. This after simplification you will get x square minus 1 upon x square plus 1. Take the LCM of a statement in bracket in numerator and denominator and simplify it. You are getting this one plus log of x plus 1 upon x. Okay. Now if you collect these terms, du upon dx and dv upon dx, you are getting answer like this. I am just writing the answer. That is, answer is equal to, this is equal to x plus, from the previous sheet I can write this is x plus 1 upon x whole power x, this is u, into in bracket that is equal to, I think I have solved, x square minus 1 upon x square plus 1 plus log, that is x plus 1 upon x, bracket close, this is du upon dx. And now what is dv upon dx? It is in above step, that is plus sign x to the power, I can write 1 plus 1 upon x, this is in power like this, and into, when I solve it, it comes out taking LCM, this is x plus 1, this is x plus 1 minus log x, this is log x, this is minus log x upon, this is log x upon, this is x square, after taking LCM, x square. This is the answer of the question. Here I have taken what? LCM x, 1 plus 1 upon x, that is LCM is x, and then x plus 1 and x into x, x square in denominator. Take the LCM and then you will get answer this one. Okay. Now come to the question number next further. Suppose question is, question number, we'll do question number 8. Question number 8. Eighth question is, question number 8 is y equal to sin x whole power x, again variable to the power variable, plus sine inverse root x. Suppose this is u, this is v. You can differentiate this v very easily. dv upon dx is what? The sine inverse root x. It means what? What is the formula to get? 1 upon under the root 1 minus x square. X is what? Root x. Again chain rule is there. Root x square and d by dx of root x. What you will get here? 1 upon under the root 1 minus x into the derivative of root x is 1 upon 2 root x. Okay. Derivative of this is 1 upon 2 into root x. Now you can write it like this. 1 upon 2 root x and root 1 minus x, both can be written as, combine these statements, what you will get? This will be x minus x square. So this is the solution of v. Now come to the u solution, because requirement is what? dy upon dx, again it will be du upon dx plus dv upon dx. I have calculated here dv upon dx. Now what is u? U is sine x to the power x. When you take log, you will get what? Log of u will be equal to x log sine x. This is the product of x and log sine x. Now derivative with respect to x. Always you have to remember I'm talking about with respect to x. Just write again that with respect to x. 1 upon u du upon dx is equal to x as it is. The derivative of log sine x is 1 upon sine x, and sine x derivative is cos x, plus log sine x as it is, and derivative of x is 1. Now, if you shift this u to the right hand side, you will get du upon dx. What will be the du upon dx? Write down. The du upon dx will be equal to du upon dx will be equal to sine x to the power x into x cos x upon sine x comes out cot x, and plus log of sine x. Now put the value of du upon dx and dv upon dx and dy upon dx. What you will get? Answer will be this statement as it is, sine x to the power x. This is du upon dx. It is x cot x plus log sine x plus, next I have solved, that is 1 upon 2 under the root x minus x square. This is the answer of the question. Okay. Now you can do the questions, I think. Now question number, we will do question number. Suppose here is a question which is important. Let's do question number 12. Let's do question number 12. Question number 12 is, that is, find dy upon dx. Find dy upon dx if it is written x to the power y plus y to the power x is equal to 1. Now here I want to tell you one thing, one formula which is very important. You can do the question like this also. Suppose somewhere a to the power b is written. You can write it like that, e to the power b log a. You can write it like this. Now here I have to write down x to the power y plus y to the power x is equal to 1 in this form, which is, I have told you, this can be written as like this, e to the power y log x and plus sign e to the power x log y. By using this formula, if I solve it, this is equal to 1. If I solve it, just look at here, y to the power e to the power y log x. I can write like this, e to the power log of x to the power y, and e and log both are cancelled. What you will get? X to the power y. Here you have applied m log n, that is equal to log n to the power m. This formula I applied here. The exponential log are anti to each other, so cancelled each other. So what, only x to the power y is left. So x to the power y can be written as like this. This is a way to do the question. You can do this question by taking u, v and taking log separately to the terms. Now e to the power x derivative is, now differentiate with respect to x. What you will get? E to the power x derivative e to the power x, but when it is e to the power t, so chain rule will be there. e to the power y log x as it is, and derivative of that t means y into log x, y as it is, derivative of log x is 1 upon x plus log x as it is, derivative of y is dy upon dx. Now plus sign again for this, e to the power x log y is as it is. By applying chain rule, you are getting here x as it is, derivative of log y, that is 1 upon y and into dy upon dx. Plus sign log y as it is, derivative of x is 1. Okay, and equal to the derivative of 1 is 0. So now next part is what? You have to collect the terms of dy upon dx. When you are multiplying this by inside terms, then you are getting terms with the having dy upon dx terms. If I collect, let's see what you will get. Dy upon dx, you will collect the terms from the left and right both. Then you are getting here, that is I will write down this as x to the power y. This as x to the power y. So what you will get, x to the power y into log x. Now I think you can understand from where I get this x to the power y. I have given you idea from here also. This is given to you. Now second is from the that is second term, that will be equal x into y to the power x minus 1. This is a statement. This statement becomes, this one becomes y to the power x, y to the power x, and when you multiply it inside, this y power solved with this, that is y to the power minus 1. And equal to statement will be, both terms will be of negative, so take minus sign common. You will get y into x to the power y minus 1 plus y to the power x log y. Now, what is dy upon dx? Dy upon dx will be, dy upon dx will be equal to, dy upon dx will be equal to, question number 12 continued. Dy upon dx will be equal to minus sign y x to the power y minus 1 plus y to the power x into log y upon x to the power y log x plus x into y to the power x minus 1. This is the answer of the question number 12. Now in question number 14, just I will give you hint, that is cos x to the power y is equal to cos y to the power x. Now you can take log, taking log both sides. So what you will get, y into log of cos x, x into log of cos y. Now you can differentiate the function in left and right both sides. When you differentiate these functions, you will get, let's see what you will get, differentiate with respect to x, with respect to x. After differentiation of the left and right both sides, you will get the terms by using product rule. you will get the terms of dy upon dx in both sides. If you collect these terms from left and right both, what you will get? Let's see. You will get, first of all, function was y as it is, y as it is. Derivative of log cos x means 1 upon cos x. Derivative of cos x is minus sin x. Okay, derivative of cos x is minus sin x. And next, plus sign, log cos x as it is. Derivative of y is dy upon dx is equal to x log cos x, log cos y derivative is 1 upon cos y into minus sin y. Again, it is not x, it is y. It means dy upon dx plus sign. Now, log cos y as it is, the derivative of x is 1. Okay. Now you have to collect the terms. What you will get? Collect the terms of dy upon dx. Let's see what you will get. Dy upon dx. Collect the terms of dy upon dx. Log of cos x. Log of cos x in left, and from right it is plus x tangent, tangent y. X tangent y is equal to, collect the terms without dy upon dx, log of cos y. This is minus, it becomes plus y into tangent x. Y into tangent x. What is dy upon dx? Dy upon dx will be equal to log of cos y plus y tangent x upon, the statement is log cos x plus x tangent y. This will be the answer of question number 14. This is the question number 14th continued. Okay. Now you can do the questions. I hope you can do the questions of exercise 5.5 now. If you have any query, then you can send in a comment box. I will send you solution for that question. Thank you. Have a nice day. Knowledgeable day.